Okay, so in this lab, we're looking at the relationship between the kinetic energy of this object moving, this plunger car, and we're looking at its velocity. That's what we're trying to get. Now, we have measured the velocity. Great. But how on earth are we going to get the kinetic energy? Well, this is where we use our big brains. So let's consider the LOL chart for this. So let's say position A is the position where it's up again, pushed up against the wall. And then let's say that position B is when it's moving on that frictionless track. And you can, by the way, you can tell that it's near frictionless because all of the graphs that were generated were pretty flat, constant velocity. They did kind of tail off a little bit towards zero, but it was pretty negligible. Also, we caught the data collection at the very beginning of it, not like later on. So the reason for that was because I wanted to get as little friction as possible. So anyways, back to this. If we define our system as the car and the spring, then we can do a simple little LOL chart. We know that at position A, it's pushed up against a wall. It's not moving. It doesn't have any height. It's on a frictionless surface, and it hasn't had any chance to build up thermal energy. It's all stored in the spring. And so then that spring energy then becomes kinetic. There's no gravitational because the height is not changing. There's no elastic because the spring is no longer compressed when it's moving. And the thermal energy is non-existent because it's a frictionless track. And so now what I can do is I can write the equation just like we've been doing, and I'm going to shrink this a little bit. I'm going to say EEL is equal to EK at B. So now the question is, can I quantify one of these? Well, yes, I can, because I know that the elastic energy, let me scroll this down. I have equations for elastic energy right here. I've got them right here. I've got two of them. Now, in this case, I should use the information that is provided to help me think about it. Well, each data point I collected, I measured how much it was compressed, the displacement, and I also measured how much force there was. So if I use this equation right here, then I can easily calculate the elastic energy. So therefore, let me go back here. I can say that the elastic energy is equal to 0.5 times the force times the spring displacement, which I'll just call x. And then that should also be equal to EK at position B. So all I have to do to find the kinetic energy for each of these trials is simply take half of the force times the displacement. And that should be it.